So, good morning, friends. This is Dr. P. Munaswamy, Professor, Department of EC. Today, we are going to discuss about one of the pulse modulation techniques. So, based on the usage of the carrier signal, you can have there are two types of the modulation techniques. So, one is the continuous wave modulation techniques. Another one is the pulse modulation techniques. So, in the previous classes, we have discussed about the different types of the continuous wave modulation, like amplitude modulation, frequency modulation, and phase modulation. So, what you have discussed in previous classes. Today, we can see one of the modulation of pulse. So, that means here we are going to use a carrier signal as a pulse. The rectangular pulses can be used as a carrier signal. Whereas coming to the continuous wave modulation, we are going to have the sinusoidal wave, which is the continuous wave, can be acted as a carrier signal. Now, in case of pulse modulation techniques, the train of pulses, a group of the pulses can be act as a carrier signal. So, this is based on this modulation. Overall, we can classify into two categories. So, according to this one, so there is one is the continuous wave modulation, another one is the pulse modulation. So, what you have discussed in last classes, there is the continuous wave modulation. So, under the continuous wave modulation, we are going to have the amplitude modulation. This is under the angle modulation. So, under the angle modulation, again we can classify into two categories. One is the frequency modulation, another one is the phase modulation. So, you know that by the definition of the amplitude modulation, frequency modulation, phase modulation, here we are going to consider the amplitude of the modulating signal, the amplitude of the carrier signal will be varying according to the strength of the modulating signal or necessary signal. Then you can say that it is a amplitude modulation. Then coming to the frequency modulation, the main parameter variation here in this modulation is frequency. So that means the frequency of the carrier signal is varying according to the strength of the modulating signal or instantaneous value of the modulating signal. So based on the parameter variation, that concerned modulation will be takes place. Here we are going to consider the frequency modulation. The frequency of the carrier signal is varying according to the strength of the modulating signal. So it is a frequency modulation. Then coming to the phase modulation, here we are going to consider the parameter of phase. So that means the phase of the carrier signal is varying according to the strength of the modulating signal or instantaneous value of the modulating signal. That is called phase modulation. So these are all comes under the continuous wave modulation, amplitude modulation, frequency modulation, and phase modulation. Here we are going to consider the parameters are amplitude, frequency, and phase. So the waveform or the carrier signal used is continuous waveform, that is in terms of the sinusoidal. The sinusoidal signal can be act as a carrier signal for the case of the continuous wave modulation. Then coming to the pulse modulation, so here the difference, the basic difference, the main difference between the continuous wave modulation and phase modulation, pulse modulation is, so in case of the pulse modulation, the train of pulses, rectangular pulses can be used as a carrier signal for the pulse modulation techniques. By the name itself, we can say that it is a pulse modulation means the pulses are rectangular pulses, a train of pulses can be used or act as a carrier signal for the modulation. Whereas what you have discussed in the previous classes, that is continuous wave modulation, the continuous wave, sinusoidal wave can be used or act as a carrier signal for the analog modulation or continuous wave modulation. So today we can see under the pulse modulation technique again, we have the two classifications. One is the digital modulation, another one is the analog modulation. Here in this, because we are considered the subject of the course is analog modulation and the analog communication. So we are going to consider the analog modulation only. So you are not bothered about the digital modulation. So in the further classes in digital modulation, digital communication, we can discuss in detail about the digital modulation. The example for this case, so there is a pulse code modulation PCM, and advanced for the PCM is delta modulation. We are not discussing for this case, for this subject, because it is analog communication system, we have the modulations related or linked to the analog only we are going to discuss. Now coming to the analog modulation techniques, there are again three types of the analog modulation techniques. So one is the pulse amplitude modulation. One is the pulse amplitude modulation. Another one is the pulse width modulation. And third one is the pulse position modulation. Here, the based on the parameters classification, we can have the again three categories. So the parameters mainly we are going to consider. One is the pulse amplitude. So that is we are going to consider here the amplitude. Second one is the width of the pulse. So the main parameter pulse width modulation, the width of the pulse or duration or time period of the pulse can be considered for the modulation of the pulse width modulation. Then coming to the pulse position modulation. Here the leading edge or trailing edge of the carrier signal. So that means based on the variation of the position of the pulse, it may be leading edge position or it may be trailing edge position can be varies. So that is called a pulse position modulation. So by the definition, standard definition, you can say that pulse amplitude modulation, the amplitude of the carrier signal is varying. The carrier signal means here pulse signal. So the amplitude of the pulse carrier is varying according to the instantaneous value of the modulating signal. So that is called pulse amplitude modulation. The amplitude of the pulse signal is varying according to the strength of the instantaneous value of the modulating signal. Then it is called pulse amplitude modulation. Then pulse width modulation. So that is the width of the pulse can be varied according to the instantaneous or strength of the modulating signal. Then it is called pulse width modulation. Then pulse position modulation. The position of the carrier pulse, it may be leading edge position or trailing edge position, is varying according to the instantaneous value of the modulating signal. So for all the cases, the variation of the amplitude or variation of the width or variation of the position will be depends on the instantaneous value of the modulating signal only. So based on the strength of the modulating signal only, we are going to take the variation. So according to the variation of the parameter, we are going to have the concerned modulation. If it is amplitude, then it is called a pulse amplitude modulation. If it is a width, then it is called a pulse width modulation. If it is a position, then it is called a pulse position modulation. So this is about the in brief about the types of the modulation under the continuous wave modulation, under pulse position or pulse modulation techniques. So under the continuous wave modulation, there are three types are there. One is the amplitude modulation, AM, frequency modulation, and phase modulation. So under the pulse modulation techniques also, there are three types are there. So especially we are going to consider the analog modulation type. That is the PAM, PWM, PPM. PAM stands for pulse amplitude modulation. PWM stands for the pulse width modulation. And PPM stands for the pulse position modulation. So these are all the based on the pulse uses. We are going to have the three types of the modulations what you discussed in previous slide also. That is the pulse amplitude modulation, pulse width modulation. It is also known as a pulse duration modulation, pulse width modulation, or pulse time modulation. All are three are the same: duration, width, and time. The last one is that is the pulse position modulation. So in a digital modulation, so we are not bothering about this one because all the digital modulation techniques are discussed in the further studies, that is digital modulation communication system. So especially for the case of the digital modulation techniques, we are going to have the PCM, that is the pulse code modulation. Another one, the advanced technique, what are the drawbacks, what are the drawbacks available in the PCM pulse code modulation that can be overcome by the delta modulation techniques. So then coming to the in detail, so we'll see the one of the modulation techniques that is called the pulse amplitude modulation. So by the definition what you discussed in the previous slide also. So that is the amplitude of the pulse carrier is varying according to the strength of the modulating signal. Then it is known as a pulse amplitude modulation (PAM). So you can have here you can see the three signals are there. So for any modulation, you know that we are going to consider three basic signals, three fundamental signals. One is known as a modulating signal. It is also known as a message signal, which carries information. Second one is the carrier signal. So the name itself indicates it carries the information. So here the carrier signal is, because it is a pulse modulation techniques, you can use the carrier pulses, train of pulses can be act as a carrier signal. So that is this one is a carrier signal. And last one is the amplitude modulated signal. So after modulation, we are going to have the modulated signal. Beginning there is a modulating signal and the carrier signal. After modulation, we are going to have the signal known as a modulated signal. So that is so because we are going to consider the PAM as the pulse amplitude modulated signal. So based on these, by the use of these three signals, we can have the modulation operation. So in the case of pulse amplitude modulation, we are going to consider this is a sinusoidal modulating signal which carries information. This is the carrier signal in terms of the pulses, and after modulation, we are going to have the modulated signal PAM, pulse amplitude modulated signal. So that means you can see the variation. So by the definition, we can say that the amplitude of the carrier signal, the amplitude of the pulses can be changes or varies according to the instantaneous value of the modulating signal. Suppose you take at the origin, this is the origin, this is starting of the carrier signal, then there is a same value. So this is the highest value of our modulating signal, amplitude of the highest value of our modulating signal. So according to the variation of the highest value, the corresponding pulse magnitude will be varies. So initially, this is all the pulses having the uniform magnitude or uniform amplitude, but based on the modulation, the amplitude of the pulses can be varies according to the strength of the modulating signal. So that here that an instant we are going to have the highest magnitude, so that the corresponding magnitude is also increases. So similarly, coming to next state, so there is a lowest value, you will get the lowest value. So according to that, by joining all these values, which reference our original modulating signal like this. So all the tops. So after modulation, you can join all pulses. So variation of the amplitude of the pulses will be according to the strength of the modulating signal only. So that we are getting variation of this signal magnitude will be varying like this in a sinusoidal form. After the joining all the pulses or tops of the pulses, so will will get reconstruct realize the original modulating signal. It will be happen at the receiver side. So by the operation known as demodulation, we can reconstruct the original signal. So this is about how the definition, how varies the carrier signal according to strength of the modulating signal. So overall, this is a modulating signal which carries the original information. Then carrier signal which carries the original information in terms of the pulses. So after the modulation, we are going to have the signal like this. Okay. So this is about the fundamental definition or meaning of the pulse amplitude modulation. Now we can see how we are going to generate the PM. So how we are going to modulate. So here you can see there are four basic blocks are there. One is the low pass filter, multiplexer, modulator, and the pulse generator. So for any modulation, there is a requirement of the modulating signal, which is a information signal which carries information. Another one is the carrier signal C of T, indicated by symbol C of T. So because in the pulse modulation techniques, we are going to use the carrier signal in terms of the pulses only. So we have to arrange the pulse generator here, which can generate the carrier signal in terms of the rectangular pulses. So both input signal So what is the purpose of the low pass filter here? What is the need of this purpose? Is so modulating signal which allows the audio signal frequency range. It is the range of the 0 Hz to 20 kilohertz only. So if the signal frequency more than or below to this one, 20 Hz to 20 kilohertz, so by the operation of the low pass filter, we can filter it. If the signal frequency less than 20 Hz, that can be filtered. Similarly, if the frequency of the modulating signal is more than 20 kilohertz, that can be also filtered. That is the purpose of the low pass filter here. Then coming to the multiplexer. So it can be multiplex the both input signals. So it can make the composite signal that can be given to the modulator. So the purpose of the modulator is, so the amplitude of the, because it is the amplitude pulse amplitude modulator, so the amplitude of the pulse carrier will be varies or changes according to the instantaneous value of the modulating signal. So after the low pass filter, we are going to get the modulator signal, which is indicated by M of t here. You can have the M of t, and this is C of t signal. So by the inputs of both modulating signal and the carrier signal, there is a multiplexing operation takes and makes the composite signal. Then it will be given to the modulator. So the output of the modulator will be like this only. You can see this dotted line resembles or joins all the tops of this modulated wave, which resembles our original signal, modulating signal. So this is about the how we are going to generate the amplitude modulated signal with the support of all the 4 block elements: low pass filter, multiplexer, pulse generator, and modulator. Okay, so this is about the generation of PAM, pulse amplitude modulation. So then coming to the demodulation. So here, so whatever the signal modulated previous generation techniques that can be transmitted through wire or wireless, the same signal that is known as the pulse amplitude modulated signal. Pulse amplitude modulated. So there is a much difference between the modulating signal and the modulated signal. So after modulation, we are going to have the modulated wave. That modulated wave can be transmitted through wire or wireless. The same signal can be received by the receiver part at the receiver side. So that we are getting at receiver part first beginning input signal is PAM signal, which is indicated by S of t. M of t is a modulating signal. C of t indicates the carrier signal. After modulation, the modulated signal will give the PAM signal, S of t. So once you have the received PAM signal, that can be given to the reconstruction filter. So that means whatever the frequency limits, that can be allowed only. So what is the frequency range you have selected? The modulated signal, those signal can be allowed by the reconstruction filter. So once you have the operation of the reconstruction, so that is then it will be given to the equalizer. The purpose of the equalizer is which compensates the original input signal values. So that means the original modulating signal can be realized or equalized by this equalizer. So that means the equalizer compensates the Rapexer effect. So that is between difference between the input signal and the sample values. So based on that, the differentiation between this input signal and the sample values, so we'll reconstruct, realize the original modulating signal M of t. So that means pulse amplitude modulated wave S of t is given to as the input signal to the reconstruction filter. Then after the output of the reconstruction filter, then it given to the equalizer. The equalizer will compensate or realize the original modulating signal strength. So that means whatever the tops of the signals and the tops of the envelopes of the modulated wave can be realized by the equalizer and then construct the original modulated signal M of t. So you take what is the difference between the modulator and demodulator. So modulator will combines the both input signals, that is the modulated signal and carrier, and enhanced the high frequency components and transmitted. So whatever the signal transmitted by the modulator, the same signal can be received as a input signal at the receiver part, that is demodulator part. Here again by the using the same frequency of the carrier signal by the arrangement of the Laplace later, then you can realize our original modulating signal. That is the essence. So this is about the generation and also demodulation. It is also known as degeneration. So that means whatever the signal we have at the transmit side as input signal, the same input signal can be realized at the end of the receiver side. So here you can insert there are two polarities based on the modulated wave. So this is first one is our modulating signal, okay, which carries information signal. So consideration of the only positive polarity, the positive half cycle only. So it is called a unique polarity, single polarity. Are considered on both sides. So positive as well as the negative side. So we will get the both polarities. So double polarity PAM. So based on the consideration of the polarities, we may have the single polarity pulse amplitude modulation, or we may have the double polarity modulation. So we are going to consider the only positive half cycles of the modulated signal or modulating signal. Then it is called known as a single polarity pulse amplitude modulation. Then if we consider on both sides, positive as well as the negative side, then it is called a double polarity pulse amplitude modulation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.